Hello students, we are solving IB Math A HL past paper questions and currently we are solving the IB Math A HL May 2021 paper 2 time zone 1 past paper. And today we will be solving question number 12. It is a question from section B of this paper. So, and you will be getting the links to all the previously solved questions in the description area in the playlist. Okay. So, without any further delay, we start with question number 12. It contains a maximum of 20 marks. Question says, the function f has a derivative given by f dash x, the first derivative, which is equal to 1 over x times k minus x, where x is a real number, x is not equal to 0. X is not equal to k because x cannot be equal to 0, obviously, otherwise the denominator will be equal to 0. Similarly, if x equal to k, the denominator becomes equal to 0. Therefore, x is not equal to 0, x is not equal to k, where k is a positive constant. We do not know whether this is important, this will be needed or not in answering the subparts, but we have to keep this in mind that k is a positive number. Okay. So we come to the first subpart A. The expression for f dash x can be written in the form of a over x plus b over k minus x, where a and b are real numbers. Find a and b in terms of k. Okay, and f dash x is given in this form and we have to convert this to this form. Okay. So I have brought the question over here and this is the f dash expression as you can see. And we have to express this in the form of partial fractions basically. So we write 1 over x times k minus x is equal to a over x plus b over k minus x. Okay. And we multiply both the sides by this denominator x times k minus x. So the left hand side becomes 1 because if we multiply the left hand side by x times k minus x, the numerator, the multiplier and the denominator will be cancelling each other and we will be having 1. And then we are multiplying this first term by x times k minus x. So this x and x of the multiplier will be getting cancelled and we will be having, okay, first let me write it, otherwise you may get confused. Plus b over k minus x x times k minus x. Okay, and let me just write the multiplier over here as well. And this is the multiplier x times k minus x. Okay. So this part and this part will be getting cancelled. Therefore, we have 1 on the left hand side of the equal to sign and this get cancelled. So we have a times k minus x plus b times this and this cancels. So it is b times x. Okay. We are having this equation. Now, if we put x equal to 0, then we have when x equal to 0 because we have to find the values of a and b. I am putting x equal to 0. You can put any number. Doesn't matter which value of x you are taking, because a and b are constants and they have the same value for every value of x. Okay, so it doesn't matter what value of x we are taking. When x equal to 0, then the equation becomes 1 is equal to a times k minus 0 plus b times 0. And b times 0 is 0. K minus 0 is k. So a times k is ak. Therefore, the equation becomes 1 equal to ak. Okay. Therefore, a is equal to, dividing both the sides by k, we get a value as 1 over k, because they have asked us to get the values of a and b in terms of k. Okay. So we have got the value of a as 1 over k. Next, we will be taking another value of x. What can we take? Let us take the x value as 1. Or better, it would be better if I take x equal to k. Because I'm a lazy person, I want to make one of the terms equal to 0. So let us take x equal to k. K is a positive constant. Okay. We have 1 equal to a times k minus k plus b times k. Okay. And k minus k is 0. So a times 0 is 0. And we have 1 equal to bk. And now we divide the entire equation by k to get the value of b equal to 1 over k. So a equal to 1 over k and b equal to 1 over k. Okay. I think we have answered the subpart A completely. Yes, so let me just write f dash x in this form. Therefore, f dash x is equal to, it was a over x, you see, it was a over x and b over k minus x. A over x means a divided by x. And what is a? A is 1 over k divided by x plus b over k minus x. What is b? B is 1 over k divided by k minus x. So this will be equal to, divided by x in the first term is multiplied by 1 over x. Therefore, f dash x, the first derivative, will be equal to 1 over k times x, or 1 over kx, plus 1 over k times k minus x. Okay. We have expressed f dash x as the sum of two partial fractions, a over x plus b over k minus x. So now we go to subpart B. And we have got C. Subpart B, hence find an expression for f of x. We are given the expression for f dash x, the first derivative, as 1 over x times k minus x. And in order to get the expression for f of x, we have to integrate f dash x. That we know. So let us write that. F of x will be equal to the integration of result of f dash x with respect to x. So this is 1 over x times k minus x dx. Okay. But we do not know how to integrate this expression. 1 over x times k minus x. We do not know. That is why they have given us the hint to how to integrate this expression. First of all, we have to express this expression in the form of sum of two partial fractions. And we have to integrate these two partial fractions. Okay? So this should be equal to 1 over kx plus 1 over k times k minus x dx. And now we can separate the two terms because there are two terms. So let us separate them. So this is the integral of 1 over, and since 1 over k is a constant, so let me take that out. 1 over x dx plus, again I am taking out the 1 over k because it is a constant, 1 over k minus x dx. Okay. Now 1 over x, we know the integration of 1 over x is ln of x, so we can write that part. But what is the integration of 1 over k minus x? If you know what is the integration of 1 over k minus x, fair enough. Else, always substitute. If you have even a a dot of doubt, or a, what should I be saying, 1 millionth or even smaller than that doubt in your mind that what will be the answer for this integration, I would suggest you to substitute. How to substitute? Let's say let t equal to k minus x. Then dt by dx will be equal to -1, okay, or dt is equal to negative dx. Therefore, we need dx, not negative dx. So, dx should be equal to negative dt. Okay. So, I can write this as, I'll be doing both the integrations in the same step. So, I keep this as it is. You can perform the integration. No harm. I'm just doing this to keep symmetry. Okay. So, and also if you do this, perform this integration before this integration, then you have to write one constant of integration. It is not that you will not be writing the constant of integration if you perform one integration before the other. If you perform both the integrations in a single step, then you write one constant of integration, it is fine. But if you do the two integrations in two different times, then you will be having two constants of integration which can be combined together maybe the first constant of integration is C1 and the second constant of integration is C2. And in the final step, we will be writing that as plus C, and we will be saying where C is equal to C1 plus C2. That can be done. But if you perform one integration before the other, then always you have to write the constant of integration for that integration that you have performed. And since you have written one constant of integration that is already present, and you are performing another integration, and you feel that for this, because I have already written one constant of integration, I will not be writing another one, that is wrong. Because you are performing another integration that will also be having another constant of integration. So you can take them as I've said just now, take the first one as C1, take the second one as C2, but you have to have two different constants of integration because you have performed them at different times. Okay. So this is 1 over k. And in place of 1 over k minus x, I am writing dt. Sorry, t. And in place of dx, I have to write dt. So negative sign, I can bring this out. Instead of writing minus dt, minus is not any variable, so I can safely take that out. Okay, this is 1 over x dx and this is 1 over t dt. Now I will be performing the two integration in a single step. This is ln of x. This is minus 1 over k ln of t and plus c. Because I have performed both of them together, so I can write a single constant of integration. That is valid because whatever were the constants of integration from both the equations have been clubbed together to give us one single constant of integration, that is c. Okay, because I have done the two integration together. But if you do them in different steps, then you should be having two different constants of integration. Okay, and which can be added together at the final step. And now I have to substitute back the value of or the expression for t. It is 1 over k times ln of x minus 1 over k ln of k minus x plus c. Okay, and if you keep it like this, it is absolutely fine. If you keep it like this, if you give the expression for f of x in this form, it is absolutely fine. And if you feel that you will be doing some more simplification and you will be rather beautifying it, then you can do it. First thing in the process of beautification of this expression is I can take 1 over k as the common factor, and it is ln of x minus ln of k minus x plus c. And we can use the properties of logarithm ln of a or log of a minus log of b is equal to log of a over b. We can use that property. Log to base anything. So ln is nothing but log to the base e. So we can apply that property. It will be ln of x over k minus x plus c. Okay. I am giving this as my final answer, but even if you give it in this form, you will be getting full marks. Okay. Now this is subpart C and it says, consider P the population of a colony of ants which has an initial value of 1200. The rate of change of the population can be modeled by the differential equation dp dt equal to P times K minus P over 5K, where T is the time measured in days and T is greater than or equal to 0. And K is the upper bound for the population. And the question is, by solving the differential equation, this is the differential equation, show that P equal to a weird expression. Okay, fine. But it is containing 8 marks. On seeing this 8 marks and this weird expression, don't get nervous. On the other hand, you should be very positive that if you can solve this question, you straight away get 8 marks. This is the positive side of it, which you have to do. So we start, okay? Because these 8 marks are meant to be given to us. So we will be just taking these 8 marks. Okay, we will be snatching these 8 marks from the paper corrector. Okay, so first of all, we write the differential equation. It is dp dt equal to P times K minus P over 5K. Okay, and we have to come to P. So obviously we have to integrate, we have to solve the differential equation, and we are seeing that the numerator is having an expression containing P. So we divide both sides by P times K minus P. Okay. So we have divide P by P times K minus P is multiplying by 1 over P times K minus P. So it is 1 over P times K minus P dp dt equal to P times K minus P over 5K times 1 over P times K minus P. And these two will be getting cancelled. So now since we have to get the expression for T, we have to integrate, and we have to integrate with respect to T because it is dp dt, it is the rate of change of population with respect to time. So we have to, in order to get the expression for P, we have to integrate with respect to T. Therefore, we will be writing this as 1 over P times K minus P dp dt, and we are integrating with respect to T, so it is dt equal to 1 over 5K dt. Okay. And these two will be getting cancelled. So we are having 1 over P times K minus P dp is equal to, I can take out this 1 over 5K because it is a constant. 1 over 5K dt. And how to integrate the left hand side? Remember, we had started with a similar expression for f dash x. So let me just bring the f dash x expression, and we have found the f of x expression as well. How did we find the f of x expression? By integrating the f dash x expression. And for that, of course, we had to convert it to the sum of two partial fractions, and we had integrated those two partial fractions. But anyway, we have integrated f dash x expression to get f of x expression. Okay, so let me just bring the f dash x expression, the original one, and the f of x expression that we got after integration. Okay, because we can substitute. Why should we be doing the same thing again? Okay. So you see, this is f dash x expression, which is 1 over x times k minus x. We are having 1 over p times k minus p, and this is 1 over x times k minus x. So the only difference is that we are having p in place of x. And after integration, we are having this expression. So I'll just be copying this expression. In place of x, I'll be writing p. Okay. So let me copy this expression. It is 1 over k ln of, in place of x, I'll be writing p over k minus p. And I'm not writing the c because I'll be writing it after integrating the right hand side. So it is 1 over 5k and t plus c. Okay. Next, we can multiply the entire equation by k. So why am I multiplying? Because I need, you see, the p expression, I'm having 1 over 5. It is, of course, e to the power of t over 5. So I'll be having t over 5. Not, there's no k over here. So I'm having t over 5k. Of course, there is a negative sign in front, but at least I can get rid of k so that I get t over 5. Okay. So that is why I am multiplying the entire equation by k. So it is ln of p over k minus p equal to t over 5 plus kc. Okay. And as you have seen that it was e to the power of negative t over 5. So, and there was no ln in the expression of p. So I have to convert this to an exponential equation. Therefore, p over k minus p should be equal to e to the power of t over 5 plus kc. Okay. And okay, we have done up to this part. Let us see what is happening. Okay, over here 1200k, 1200 was the initial value. That means when t is equal to 0. Okay, so let us, p is equal to 1200 when t is equal to 0. Fine. So let us do one thing. And we are not having, in fact, e to the power of kc. Okay, let us see what can we do. When t equal to 0, we know p equal to 1200. So let us substitute that. 1200 over k minus 1200 is equal to t equal to 0. That means 0 over 5 is 0. So e to the power of kc is equal to 1200 over k minus 1200. And e to the power of kc is a constant. Maybe e, it is a constant. K is a positive constant. 1200 over k minus 1200 has to be a constant. Fine. So we have got the value of e to the power of kc. So what we can do is, I can write this, I can separate this in fact. This can be written as e to the power of t over 5 times e to the power of kc. And now we know the value of e to the power of kc. So we can write the same equation, this one, as, okay, let me write, because P is equal to 1200 when T is equal to 0. Okay. So now we come again to the expression, the equation that we have got. It is P over K minus T is equal to, now I'm writing this one over here, 1200 over K minus 1200. See, we have got, previously we did not know where to put that 1200. We knew that 1200 is the initial population, but how to bring it to this equation, we didn't know. But now we are having the number 1200. Okay, so we should be happy about that. And we have got e to the power of t over 5 as well. So this is e to the power of t over 5. Fine. And now we have to make p the subject. Therefore, we cross multiply. We can cross multiply. Let us see. It becomes P times K minus 1200 equal to K minus P times 1200 e to the power of t over 5. Sorry. Okay, and I have to actually expand the right hand side. So this will be equal to K times 1200, or I can write 1200 K. 1200 K e to the power of t over 5 minus P, or minus 1200 P e to the power of t over 5. And now I add 1200 P e to the power of t over 5 to both the sides to get P times K minus 1200 plus 1200 P e to the power of t over 5 is equal to 1200 K e to the power of t over 5. And now I will be taking P as the common factor, and it becomes P K minus 1200 plus 1200 e to the power of t over 5 equal to 1200 k e to the power of t over 5. And now finally I have to divide the entire equation by this part. So it will be p equal to 1200 k e to the power of t over 5 divided by k minus 1200 plus 1200 e to the power of t over 5. Okay, next, now let us see what is the expression for p that they have given. It is this one. Okay, the numerator is, you see over, we had 1200 k e to the power of t over 5, but they are having only 1200 k. And in the denominator, we had 3 terms and they are also having 3 terms. And in place of t e to the power of t over 5, they are having negative t over 5. But in any case, in order to get rid of e to the power of t over 5 from the numerator, we have to divide the numerator and the denominator by e to the power of t over 5. Okay, so let us do that. So we can divide the numerator and the denominator by e to the power of 12 t over 5 to get the numerator as 1200 k. So we have got the numerator correct definitely. And then it will be, this will get multiplied by e to the power of t over 5. This also will be getting multiplied by e to the power of t over 5. So just let us combine these two. We are we are dividing by e to the power of t over 5. Okay, so we are dividing this by e to the power of t over 5. Yes, and the second term is 1200 e to the power of t over 5 divided by e to the power of t over 5 will be 1200. Okay, and since this is in the denominator, if I want to bring it to the numerator, it will be e to the power of negative t over 5. So p becomes 1200 k over k minus 1200 e to the power of negative t over 5 plus 1200. In fact, I can draw a better line, I think. Okay. I feel that this one is better than the previous one. And let us check whether we have got the same expression. Okay. So you see, these two expressions are exactly the same. In the numerator, we are having 1200 k over k minus 1200 to the power of times e to the power of negative t over 5 plus 1200. Exactly the same. So we have got 8 marks. 8 marks. Are you happy? This is a part D and it says at t equal to 10, the population of the colony has doubled in size from its initial value. The initial value was 1200, so doubled means it will be 2400. Find the value of k given your answer correct to 4 significant figures. We are actually used to giving the answers up to 3 significant figures, but this time it is up to 4 significant figures. We have to remember this. Okay. And the population, what was the population expression? This was the population expression. I can bring this expression once more to this, for this question, like this. Yes, this is the population expression. So T will be equal to 10 and the population will be 2400. So 2400 is equal to 1200 K over K minus 1200 e to the power of minus T is 10 over 5 plus 1200. Not at all a good looking equation, but we have to solve it. Of course, we are having the calculator. Fine, fine. So let us use the calculator. We start with 2400. We will be using the INSOLVE algebra numerical solve. It is 2400 equal to 2400 equal to, okay, equal to, and then there is this fraction. So fine, there is this fraction. Numerator is 1200 K. 1200 K. Denominator is K minus 1200 within brackets K minus 1200 to the power of minus 10 over 5 is minus 2. Minus 2. K minus 2, 1200 to the power of minus 2 plus, sorry, e to the power of minus 2. K minus 1200 times, okay, times e to the power of minus 2. Okay. And plus 1200. Plus 1200. And now we have to declare the variable. It is K. Fine, I think I have given all the details. Now let me press this, enter. Okay, 2845.35. K value is 2845.35. Up to 4 significant figures, it will be 2845. Okay, so using GTC INSOLVE, K is equal to 2845. Up to 4 significant figures. Okay, fine. So we have given the value of K. We are done with subpart D. Now we get to the subpart E question. Now this is subpart E. It is the last subpart of the last question of this paper. And it says find the value of T when the rate of change or the population is at its maximum. The population expression was found to be this. And rate of change of population, obviously with time, is dp dt. And this is at its maximum. So when is at its maximum, then this its derivative, that will be the second derivative of p, will be equal to 0. So d2p per dt square is equal to 0. And we have to solve this equation for t. This is our target. We will be using the insolve. Let us try. So it is insolve, algebra, numerical solve, insolve, and then I have to go to the second derivative. Okay, and it is x. And what is this expression? Can I bring this expression? Let me try actually. Okay, control C and control P. Thank you. I'm thanking the computer, the calculator actually. Okay, and I have to substitute the value of k over here. It is 2845, so I'll be substituting that. 2845, and over here also I have to substitute 2845, and over here I have to make it as minus, it is minus t over 5, so I have to change it to minus x over 5 because I'm differentiating with respect to x. So it will be minus x over 5. Fine. Okay, I think I have done the necessary modifications. I hope so. And I come to this part. This should be equal to 0. Equal to 0. Okay. And I have to declare the variable as well. Right. And let's see what happens. Oh, I have got some value. They did not give me any error. Again, thank you. So, what is it? 1.577. So up to 3 decimal places, or rather, sorry, up to 3 significant figures, 1.58. So we have to give the answer of t as 1.58. Okay. So we write the answer as, therefore, or I can write using GDC. In solve, t is equal to 1.58. Let me see once more. It is 1.58. And t was in days, so it is 1.58 days. Up to 3 significant figures. Okay. So we have completed the whole paper 2, May 2021, paper 2, time zone 1 question paper. And thank you for staying with me till the end. And uh, you are seeing, I am planning to start my group online math tutoring sessions for IB Math E, SL and EGL students. I am Nilanjana Sanyal and I tutor the IB Math E, SL and EGL students from India and from outside India. And I'm planning to start with my group online tutoring, math tutoring sessions from the month of July. So if you are interested in joining my classes, you may contact me. The email ID is being displayed. The uh, WhatsApp number is being displayed. So you can mail me, you may text me, you contact me to know the details. Okay. And we will be meeting with our next paper. We will be solving the question 1 of the next paper. So till then, bye.